Hello everyone. Our next practical is on homology modeling. As we have discussed in the theory sessions, homology modeling is a model of secondary, sorry, tertiary structure prediction of proteins, and there are different methods like ab initio modeling and other things. But now, homology modeling is actually based on an existing template of similar structure, and based on the existing templates, our unknown protein will be modeled using such softwares. And a free tool that is available is provided by the Expressive Proteomics tools. That tool is known as a Swiss model server. You can Google for Swiss model server, and the link will be there. You can open it. And before starting the modeling, you require to log into the website. If you don't have an account already created, you can create the account just like creating any other account in any platform. So you can create with your own email, and details, credentials can be given, and you can create an account. Once you create the account, you can log in. So here I have already created an account, so I am logging. Now here is my account. So everyone make sure that you create your own account with your email ID and you log into the Sys model server. So once you log into the server, you can start modeling. So for starting the modeling, you require a protein sequence. Okay, you require a protein sequence. From where you will get the protein sequence? Previously we downloaded and we attempted many proteins, but now they're all gone. So let's do one thing. You can download a new protein sequence. I'm going to the UniProt. So you have to search not in the help, in the UniProt KB. So in the UniProt KB, I'm searching for insulin, then Homo sapiens, insulin-like, insulin receptor. So this is insulin itself. Homo sapiens, insulin 1 ton. So this is a protein of interest. I want to model it. So at the bottom there will be the sequence. So this is the protein sequence. You can download the FASTA. So this is the FASTA sequence of the insulin, 1 ton. I'm copying it. So once you copy that sequence, you can paste it here. Or the FASTA file can be uploaded by upload button. If you have already downloaded the file, you can upload it, or you can paste the sequence. Now you have to search for the templates. So for what the Sys model is doing is If you give an input sequence of unknown protein, then that sequence will be, say, blasted against the existing database to find similar sequences. So if any protein with a non-structure is having a similar sequence, they will be listed as a possible template. Okay, so you are searching for templates. Since it is already taken from the database, it is suggesting the existing one. Now you can select modeling, paste it, and I am removing some of the regions of the protein. Okay, so now let's see how it works. Since the exact match is not available in the database, it will search for the available templates. In the previous case, the exact sequence is available because we didn't remove any of the sequence. Okay, so once you modify the sequence, because if you have your own sequence, it will be different from the database sequence. That's why you are going to model. If the model is already existing in the database, like that of the insulin with one ton amino acid sequence, then there is no point in further modeling it. The structure is already available that you can download. So if there is no available model, your sequence is a new one, then you want to model it based on the existing sequences. So in this case, I removed some of the amino acids from the one-ton amino acids of the insulin. So it will not match with the existing one in the database. So you can model your sequence, your new sequence, with or by comparing with the database sequence, and accordingly you can model using that template that is downloaded. Here it will take time. Actually, it is searching in the database for similar sequences and finding appropriate templates. Okay, now you have the uh, results. There are templates available. So the insulin, it's 87% identity is there because we deleted some of the regions. That's why there is now 100% identity. And in this case of insulin, there is a 96% identity is there. Okay. So you can select the sequence with the maximum identity because this is the one with the 96% identity, but still the score is higher for this one also. You can select both of them, or say this one is already by default it is selected, and a model is shown here. Okay, so you can expand it and you can click on build model. Okay, so this is the target sequence and this is the database sequence. So I have deleted two regions from the database sequence. So using these targets, the protein can be modeled. Okay, this blank represents the region that I have deleted from the database after downloading. So there will not be exact match for uh, this region, but it will model based on that one. Okay. So you can click on build model. You can build multiple models with multiple templates. So there are other softwares, advanced softwares, which is or that are used for combining multiple templates and building a single model. So in this case, actually, you are using a single template and your target. Okay, so target and template is directly matching, and it is creating a model based on that one. But there are advanced softwares which uses multiple some templates simultaneously. For example, your template is missing this region, so it doesn't have any complementary part in the database in this sequence. Okay, so this region can be modeled. So if a second protein or second structure is having, for example, this one is having that region, a matching region, then that can be used for modeling this region. So multiple templates can be simultaneously combined together, and that aligned sequence will be used for modeling the final protein. That's how advanced modeling is performed. Okay, so once the model is prepared, you can download it. So we are modeling it, one template and or two templates can be selected, then it will model. So now you have the q-mean score of 5.6 is there. So this is having a high score. So this is a better model than this one with 5.2. Okay. So these are all indicators of the quality of the model, q-mean score. So now, once the model is prepared, you can download it in the PDB format. So now I have downloaded the model. Okay. So that model can be visualized in RASMOL, for example, RASWIN software, which we have downloaded. So that RASWIN can be used for visualizing once the model is downloaded. Open. So this is the model that we have created. So this is the possible model. Okay. So this is not 100% accurate because some regions were missing, and the model is not having that much quality. So if your template is optimal and your modeling method, this free tool, that is Swiss model is a free tool, and it is not that much efficient in modeling. So basically, good quality journal publications won't accept a model based on Swiss model. There you require advanced softwares like Modeler or such packages, professional packages like Schrodinger, etc. That needs to be used for modeling. But for our academic purpose, to understand how this works, these Swiss model software is okay. That model can be downloaded and can be visualized uh, in the RASMOD software. So this is how a model is created, a three-dimensional model or of the protein is created using the primary sequence in Swiss model. Okay. So you can also look into the q-mean scores and z scores, etc. And in the theory portion, we have already described what is mean by q-mean scores and z scores, etc. And what is how it becomes relevant in determining the quality of a such a models. So anyway, you can look into that one, and you can save the results uh, as screenshots. So that's all about uh, modeling, homology modeling.